So we are going to look at how we determine the domain and range of a linear function in mathematical problems, and also how we determine the domain of range of inequalities, and look at real-world examples of each. So in general, almost always the domain and the range are real numbers. If we don't consider the real-world examples, we can look at a few graphs. For the function of f of x is equal to x, we see the graph is looking like this, extending in both directions. So we can see that the domain is all real numbers and the range is also all real numbers. So let's look at an inequality when y is less than or equal to 2 over 3x plus 4. Even though half of the graph isn't shaded, but we can still see that all of the x values are covered and all of the y values are covered. Let's look at some real-world examples. So for linear function, let's say I have a problem that says an athlete has already run 3 miles. He is now running at a speed of 8 miles per hour. How far would he have run after x hours? So let's set up the question. Let the number of miles he ran be y, and it's already given that he ran for x hours, so he runs a total of, he already had 3 miles, so 3 plus 8x, and we sketch the graph looking at something like this. So we can see that the domain, even though the domain seems like it's all real numbers, however, we know that he already ran 3 miles, so y has to be greater than or equal to 3. And for domain, we can't run for a negative amount of hours. We have to run for at least 0 hour, right? So x has to be greater than or equal to 0. So let's look at the domain of and range of linear inequality in a real-world example. The question goes that an athlete must run at least 20 miles every day. He has already run 5 miles. He is now running at a pace of 4 miles per hour. How many more hours does he need to run? So first we have to determine what we want our y and x to be. Let y be the number of miles he ran. And let x be the number of hours he ran. So he has already ran 5 miles, so we know that y must be greater than or equal to 5. But it also says that he must run at least 20 miles every day. He has already run 5 miles, so without solving the problem, we already know that y is greater than or equal to 5. Of course, later we know that y has to be greater than or equal to 20. And for domain, we know that he can't run for a negative amount of hours, so x has to be greater than or equal to 0. And after we set up the equation, which is 5 plus 4x is greater than or equal to 20, 4x is greater than or equal to 15, we have that x is greater than or equal to 3.75. So here comes the question. When do you know that x has to be, when x and y are discrete or continuous? So in real world, we can run for a fraction amount of hours. For example, I can run for like 3.5 hours, which is 3 hours and 30 minutes. But when we're buying things like ice cream or potatoes, you can only buy a whole number. So that's when you know that x and y can only be whole numbers. Yeah, that is it. Thank you.